This conference will now be recorded.
So hello all. I'm assuming that you can all hear me. There's a couple of good news is it looks like we're almost done with all the modifications for the First Amendment to the revision 2 of immersion requirements. I've shared everything on my screen. Just going to split this so we can keep the change tables. Yesterday in the fluids and materials group, which is the new name of the former material compatibility group, as they are responsible for everything that pertains to the fluids and material compatibility. We've processed quite a few points, and this is listed here in the table of amendments as part of the first amended second revision. We've been able to slam down the dielectric strength, flashpoint, updates to volume resistivity, the requirement for additional temperatures to measure specific values on. That has now been agreed upon. I shouldn't forget the removal of the estimation ability for a 1 millimeter value for the dielectric strength. As in the oil and gas industry, it's common to measure that with 2.5 millimeters, whereas in IT industry, board design is done with 1 millimeter reference. So to avoid any confusion in the electronics industry, the requirement is to actually measure with that 1 millimeter distance as well. Let's see, a couple of small modifications which have been green lighted. Additional boiling point is now pretty much done, and a small change to the biodegradability format. There's a couple of items that are still pending text approval, but that's only for how it's written down in the document, not so much on not so much on the merits. I see a question from Jeff. Guys, please do interrupt me while I'm speaking. I'm keeping poorly track. I'm pretty poor at keeping tracking of the comments while we're going through the document. The question is, how can we gain access to the document? The link in the meeting invite messages error when accessing. All right, good point. Let me check that for you. I'm just going to go and verify share. Right. Okay. Anyone with a link can comment. And I'll verify this link with, let me just see what this points to. No, it's a broken link. So I'll post a link to this document in the chat. No, I'm gonna do this differently. I'm just gonna generate a PDF to comment in, otherwise we're losing the formatting. So I'm just gonna put this back on restricted. Just bear with me for a sec. Guys, you can still hear me, right?
Yep.
Yep.
Yeah, it's so quiet, so I'm just mumbling by myself. It seems. Just now and then, let me know if you're still in there. So I'm not all by myself here, just doing the recording stuff. All right, and I'll share the PDF accordingly if that works out. Yes. Okay, and share. Where's the, here we go, amendment 2, so that's share. Anyone with the link, comments, copy link, done. So I'll post it now in the chat. The problem is, as soon as somebody opens the document in Google Drive or in Google Docs, it screws with the overall formatting and automatic links in the document. So I'm trying to avoid that. I hope you guys don't mind, since it's so close to finalization. I don't want to be messing too much with the formatting. But the PDF is now can now be opened. So as mentioned just before I started the recording, what is marked in light blue is still pending discussion with fluids and materials group. What is marked here in purple is still pending response from the ACF community. What is yellow is still what we have open to discuss among ourselves. So that's 2 points here. One is the thermal loss factor, and I think that's what we can spend most of the time on today. And the second one is the high safety requirement, where regarding NFPA, suggestion was to always include the fluid volume detection, so we can visit that. Happy to visit that first. Is there a suggestion for an order here, whether we're going to discuss the thermal loss or the fluid volume detection first? Any preference?
About fluid loss.
All right, we're heading over to 5.3. I'll just put this one here on top to keep that context there. Where are we? All right, so Chapter 5 contains the feature classification. So we have a set of minimum management requirements for the management system. Then we have requirements if you want to call yourself a thermal optimized system. There's a list of items that you need to comply with. I'm just repeating this for the sake of recent additions in the community here. We have a set of high safety requirements, if you want to call yourself high safety, which contains all the requirements from thermal optimization, but with the addition of quite a few extra features that you need to have in place for high safety. And then we have high availability, which again contains everything from high safety and thermal optimized, but also allows full redundancy and full resiliency. The suggestion made, and I genuinely don't remember who made the suggestion, but it's something that we're gonna discuss then, is that the dielectric fluid volume detection, which is listed over here as part of high safety, and water/leak detection, which is these two, to move this from high safety to minimum requirements. Does everybody understand what I'm trying to explain? Does anybody not understand what I'm trying to explain? Core people, small group, we can all speak up and join the conversation. We all know what we're talking about.
Rolf, I have a question here because I wasn't part of the group when high safety versus minimum requirement was discussed. My understanding would be that high safety is indication of the degree of safety of operating, the consideration and the design for safety in designing the system.
Correct.
And minimum is like exactly what it says, absolute minimum. This feature has to be there in order to actually qualify.
Precisely.
Is that a good assessment? Okay, perfect.
Absolutely. And the high safety is an optional classification. So, but if you have a technology which doesn't comply with that, you cannot call it a high safety system. It doesn't mean it's unsafe, but you don't qualify for a high safety flag. Now, any Any thoughts on moving the dielectric fluid and water detection to the minimum requirements?
A question for me, in terms of minimum requirements, would we then have to specify what type of detection system?
No, this is not a spec document. This is a requirements document. So in terms of a requirement, it states that you must have it. It doesn't specify how you need to have it implemented. It's this document is meant to ensure a certain level of technology and maturity of products that come in through Open Compute. So yeah, does that make sense?
Absolutely. Thank you, Rolf.
Michael, do you have views on this one? This is clearly linked to NFPA, so maybe you have some thoughts on this. Should this be a minimum requirement?
I think it's the right thing to have to move it to minimum requirements. I would think a code official would want to see that, make sure that there is some way to notify operators that you either had a leak or you had, volume that was below what it needs to be. So I think it's the right move to move it there. I'm sort of right now, I'm not a little blank on what we could reference or what we can point to that would sort of validate validate the requirements.
So we don't need to solve that one. So I think at least I know that these are things that can be implemented in a technology. Simply because the Aspertus technology qualifies for all of the requirements anyway. So I know that you can implement it fairly easily. But I'm also aware that some may choose different methods, so it's not up to us to specify how it's done.
So it's yes or no, basically, right?
Sorry, what's that? Can you repeat? Go ahead, Michael.
No, basically it's a merely yes or no. You should have capability in your system. That's it.
Correct. And do we want to have it as a minimum requirement that every technology must always have it? Is it something that you would want to enforce anyway?
I would
for
think
example.
So. Yeah, I would think so. Yes.
So you would require it from any technology that seeks UL certification?
Yeah, I would think so.
Anyone else? Are there no solution vendors in here today? No Submar, no GSE? Oh, goodness.
Rolf, I had a question. It's Alistair here from BP. On the screen, we're seeing temperature sensor and pump operational status. Is there any fluid level sensors, or are we intending to use a temperature sensor as a proxy there?
The fluid level sensor is part of the conversation right now. So currently that's listed on the high safety only as a requirement. And the suggestion is to move it to the minimum requirement.
Got it. Understand. Sorry I've taken so long to get to the conversation. Understand.
No problem. I appreciate you asking. There's no such thing as stupid questions. So appreciate the question. Okay, so I don't mind. I think this has been on the list for quite some time. If everybody agrees, I'll go ahead and move it.
Yeah, Rolf, the only thing I might think of is as we move forward, and there are a lot of different design form factors, that it might be an and/or statement, but I kind of defer to the team here who are designing the systems. In other words, level fluid volume level detection and/or leak detection. If the level changes, then that would indicate a leak, and if the leak detection signals, then that would indicate a fluid level. I could see with different form factors that maybe one or the other and not both might be sufficient.
Well, they do serve different purposes, right? Leak detection is obviously leak mitigation, whereas the fluid level may be affected by removal of components or addition of components.
Oh yeah.
right? So there is a significant difference, and the water leak detection is one that is different from a dielectric fluid level of dielectric fluid detection.
Well, the other thing I would think is
the slash, I guess, should be an and sign.
right. Well, the other thing I would think is a leak potentially could have hazard to the facility versus, well, they could both have.
It can definitely be a hazard for the IT operation as well as
Yeah,
the
right.
facility.
Yeah.
And they both can be, right? So if a tank overflows because there is a block, so if you have, for example, a CDU with shared tanks and one feed is disrupted of some kind and other tanks start overflowing, I can imagine that being a potential concern. I don't know, but I can imagine.
So Rolf, one other thing I don't think we talked about is especially for the low boiling points fluids, there is a general tendency of high volatility and then fluid loss in the system. So we are just addressing, thinking it's just a leak, but should also keep that in mind for those such fluids.
Yeah, so fluid loss detection, wouldn't that fall on the dielectric fluid leak detection?
I mean, what I'm saying is, I think we are just addressing saying that the reduction in the levels, maybe it is coming from the water, the leakages, but I would say I think even volatility also can cause reduction in the fluid levels.
Right, so this is not about addressing the causes. That's more for the hardware management work stream. This is just about minimum requirements. What technology needs to be embedded? So regardless of the cause of potential problems, what are the minimum mechanisms that you need to have in place?
Could the detection method be also manual, meaning it's not based on any sort of sensor technology? It's somebody has to inspect the tank periodically.
That is not what these requirements address. So these requirements address a feature and capability of technology,
Right,
not of human intervention, right? So maybe there is some ambiguity in the way that that's written, but I think the intention of this text is clear on that level. So it's these two lines that either need to be moved or they remain specifically for high safety requirements. Let me do a roll call.
Yep.
So we can all have a say, and I'll start at the top of the list with Michael.
Yes.
Mick. Hey Mick,
Yeah.
welcome.
Yeah, sorry. So from a hardware management perspective, at minimum or high safety, they both have to appear in the management interface. So
Yes. So the question is, do you agree with making this a default requirement, a minimum requirement instead of a high safety, an optional requirement?
Well, based on my workstream discussions, yes.
All right, Puneet.
Absolutely.
Alistair.
Yes.
Amy.
Yes.
Bo.
Definitely yes. Yep.
Jeff.
Yep, I'm okay with it.
Kevin.
Yes, I agree.
Martin.
Yes.
Miguel. Can't hear you, Miguel. You are off mute, but don't have audio. We'll just move on to Zineng.
Yes.
Miguel, if you have a different vote, feel free to put it in the chat. But I think we have an overwhelming majority stating that this has to be part of the minimum requirements. So I just added it to the minimum. Okay. Slam dunk. It's good. I'm just gonna mark this as complete so I can process that. Okay, then we have the thermal loss factor. I'm just gonna pull up a slide. Just bear with me for a sec. I did add it already to the concept deck for the regional summit. I made a proposal some time ago for let's say, sorry, I need to do this one step at a time. Okay, yeah, I made a proposal some time ago. Let's see if that works. Yes, for a thermal loss factor analysis. So to establish a thermal loss factor, originally we had stated stated it as a percentage that should be listed. It gives an indication of how much thermal leakage there is from an immersion tank to the facility, to the room that it's positioned in. Not 100% of the heat will never be rejected to the cooling infrastructure because a tank itself will radiate some heat. There may be some thermal loss through gaps and cracks between a lid and the tank, or in other ways. So even if a tank is properly connected to the water circuit, there will always be some impact on the room that a tank sits in, as long as it's operational. The struggle we've had over the past years is, okay, how do we assess the actual thermal impact of a solution? So the proposal that I came up with some time ago in this call was, hey, why don't we take this from a completely different approach? Since every operational tank will at some point reach equilibrium in terms of a cooling supply and a thermal generation inside the fluid, a certain amount most of that heat will be rejected through the water system, but a certain amount will always leak. But a system will likely operate at a certain temperature compared to the environment, a certain temperature compared to the ambient temperature. So the assessment proposal that I did was, okay, to assess how much heat is being lost to the environment, what we can do is create a situation where you don't reject heat to the water system, and then find out how much heat needs to be generated to maintain a specific temperature without any cooling. And that should indicate the amount of heat that is being lost to the environment. So a simple process to facilitate that is, to assess this, is to shut off the cooling supply, basically shut off the water supply from the facility water system, close the lid, assess the room temperature, which let's say 20 degrees C or 25 degrees C, and then add energy into the dielectric fluid by means of electricity or a heating element or IT equipment until the fluid reaches a 20 degrees Celsius rise compared to the ambient temperature. And then reduce that energy input so that that temperature is maintained and stable for a certain amount of time. I just put in 24 hours here. It could be less, could be more, I don't know. And that's energy inputs, the electrical inputs, which maintains that exact equilibrium of 20 degrees Celsius rise compared to the ambient temperature, should equal the thermal loss to air in a normal operational environment where the system is running with a 20 degree difference between ambient and the immersion fluids. Does this make any sense to the people here on the call? And is this something, does anybody here feel that it doesn't work, or that it should be different, or is this indeed a suitable approach to assess the thermal loss factor? Does everybody understand what the...
Yeah, I'll go first, Rolf. I think that
Yeah,
it makes sense. It makes sense as long as we can log the power over time, which will obviously fluctuate over the 24 hours if there is any change in that room temperature of X. Otherwise, we've just got an average power, and we can times it by 24 to get some energy. I think another thing that we've looked at Castrol before is warming up fluid to what you've said there as X plus 20, and then looked at the temperature decay to measure losses and time taken to reach a certain temperature, for example, X plus 15, X plus 10, X plus 5, etc.
Right, so...
But this looks better, actually. This looks more scientific.
Yeah. So the relevance of this figure is to give an indication to a facility designer how much air cooling needs to be put in place.
Yeah.
Right, because it cannot be zero. It just cannot be. But there is a lot of ambiguity, and there's different ways in which vendors so far are approaching the thermal loss, and there's no unity in this. And this seems to me like a very straightforward approach, which can be the same for everyone. So you think this will work?
Well, this makes sense. Yeah, this makes sense to me, Rolf. And as a starting point for X, what about 20 itself for discussion? Yeah, well, to start discussion.
That's actually a question I would have. Would it matter at all what X is, as long because the thermal loss is driven by the delta, not by absolute temperatures, right? Or is that too easy?
That's a good question.
I can imagine replacing X by ambient.
Yeah, I thought we're really trying to measure the amount of heat transferred to the air, and I thought that was done through the measurement of convective heat transfer, which would be
correct.
The heat transfer area. I guess the thing is you have to know what the convective heat transfer coefficient for your system is. So this would help people determine that convective heat transfer coefficient. And then after that, all they have to know is the temperature differential between the outside air and their system, and then with the area of the surfaces, they should be able to calculate that amount of energy.
Yes.
So
the point
is
that with the different types of solutions, that calculation becomes really ambiguous to predefine, right? So, which is why I've proposed this based on an actual test of a solution like this, and that should be as accurate as it can be, right?
Yeah. I mean, this would be used to determine the convective heat transfer coefficient. This study, because exactly. You need a delta T on your system, and then so this would be done at by a tank manufacturer, right?
Correct.
Yeah.
Because the outcome of this should be listed on a spec sheet. And we want to make sure that this information becomes comparable between vendors, so that there's no difference in assessment of the thermal loss factor, right? So, and with an enclosed chassis system compared to an open bath system from Submer, that doesn't compare, and also not between a Submer tank and an asparagus tank, or a GNC tank, or TNG core solution. They would all behave differently, right?
Mm-hmm.
Does anybody see reasons why this should not be appropriate?
I think, Rolf, it's Ali again here. the room itself, we're presuming that the room has no forced air movement through it, but the room itself will change the results due to radiative cooling or radiative heat transfer, less so than obviously the convective.
I think that might be
Might want
a
to be a
good
comment on that.
addition. Yeah, it might be a good addition to make sure that the ambient is not. Is there a term for that? To make sure that the ambient is not ventilated or still or something?
Yeah, I guess it should be in a still air area, and the room should be of a certain size. I mean, you could optimize a
Does
room
it
for
matter as well?
increased
Because
radiative.
as long as you keep an eye on the delta, does it really matter if there's some fluctuation along the way, as long as the delta remains steady? I do understand that if you put a fan system or an air duct, point an air duct directly at the solution, that it will convect more. But so to make sure that the air is not flowing, I think that is it should be reasonable. Okay, let's move this. If there's no further comments, might as well move this to a vote then.
Yeah. So I put 2 links in the chat that actually show that, they kind of give a little bit more explanation of what you're showing if somebody's interested in learning more about it. Yeah.
Engineer's Edge. Is this a bigger version of the engineering toolbox? It is the engineering toolbox.
Yeah, this is just another version of it. But this is nice because if you scroll down on the page, it actually gives examples of calculations and everything. So
yeah, so the point that we were trying to avoid is to implement calculations.
Yeah.
And do it with a practical measurement, because calculations leave a lot of room for people to put in optimistic figures. Let's call it that.
Yeah, I mean, but the thing is if somebody does the measurements and they're concerned about how accurate, their values are, they can use something like this to verify it. So.
Okay, shall we put this to a vote whether this is the approach you want to embed in the requirements? Any objections to the voting?
Nope.
All right. Oh, hang on. Comments from Amy. Amy, please do just interrupt me if you want to add something. You want to speak up, Amy? Okay, guess not.
I think what Amy's saying though is similar to what I was trying to say, but Amy's written it better than I said it.
Yeah, sorry, I was double
Amy.
muted on my side, so I was talking to myself over here at Looperzall. Yeah, I think
that's always good.
Yeah, I was like, why isn't anybody commenting? Well, that's talking to myself. So it was really getting at what the BP team raised, which is if you don't have consistent test facility site to site, how comparable would that thermal loss factor be from one system to the other? If you're not controlling for the ability of the environment to remove that heat. The other piece is just a lot of these facilities, I think they're not going to be able to modify their own forced air system. So you mentioned just turn everything off. I don't know how flexible that actually, or how possible that actually will be in some of these test facilities. So just a consideration in terms of being able to benchmark site to site or even system to system.
It's a good point. it's a really good point. But then still, I think even if you put a small tent around it, you avoid the airflow directly onto a tank, right? So requiring a still air environment, I think that should be doable by itself, right?
Yeah, I mean, if somebody could put up a temporary, if they have a problem where they're in a facility that they can't shut off the ventilation during the period of this test, they could always put a booth around it, like a plastic enclosure, that's made of
Yeah, just even
plastic.
canvas. I mean,
Yeah, like, two layers of plastic, put on a PVC frame would be adequate to isolate it, to get a pretty close estimate of this value.
okay. So would this be a sufficient description? I guess, I mean, you don't need a specialized environment for it, right, to do this?
Ralph, the only thing I'm not expert on any of this, but I'm just wondering, do you need to have any factors in controlling humidity or just temperature?
No, I would say just let's not overcomplicate things, to be honest, and just keep it as simple as we can, because that was the huge challenge we had in creating something that is simple enough so that everybody can do it. And don't get me wrong, it's aimed at the manufacturers, so there's only a handful of those.
Yeah.
And each one of them has their own labs where they can do all sorts of testing, and that includes Asperitas as well, where it should be really simple to execute a test like this.
Okay.
Personally, I have no problem with a test like this. This is something that can very easily be done with an Asperitas system, and I can only assume that it's very simple to do that with other systems as well. And if somebody wants to go through the effort in manipulating the air temperature, I don't think it will have a significant impact, but that's my gut feel. I don't think that it will result in a kilowatt more or less. If anything, it may have a difference, an impact of a few watts, but not to a level of significance on the scale of 0 to 100 kilowatt tank, to be honest.
Okay. Got it.
Right. So with this outline, we're still with 10 people. Michael, would you like to see this in the as a better input for thermal loss factor?
Yes.
Alistair?
Yes, but I'm adding a comment into the chat box.
Oh, sorry. You said?
Sorry, I'm saying yes, but I am adding a comment into the chat box about caveating some of the discussion that we've had just now.
Okay, so is that a yes but, or is it just a yes?
It's a yes and.
And,
but,
okay.
Yeah,
what is the and?
Yeah.
You can just explain it here if you like.
Yeah, so, well, I'm just agreeing with you that humidity will have an effect, as will building size, wall material, wall color on radiative heat transfer, but this is minimal, so therefore I just recommend adding a comment. This is the and on the bottom of this to say that we understand that this is a factor, however, it's expected to be negligible. Therefore, we want to do this testing in a room with no deliberate forced convection, but we don't need to control humidity, and we don't expect everyone to have a white matte wall of a certain size, for example, surrounding the test piece. And I think that, yeah, I've gone far too scientific maybe into this, but it's been a good thought process maybe.
What about just this? Does that work, Alistair?
Works for me, yeah. Actually,
right,
sorry,
cool.
add in the humidity and radiative heat transfer deemed negligible. Sorry to be the disruptor today, Rolf.
No, this is not disrupting. This is the point of these meetings. So thank you very much for making it better. What about this? Just pointing at any variations caused by this.
Yeah, should that be negligible versus negligible? Neglectable or negligible?
Yeah. So
Okay, there you go.
how do you spell this? Okay, that's it. That's the English spelling I was concerned about. I was trying to avoid, but thanks. Okay, who's next? Amy?
I am a likely yes, but I'd honestly love to get feedback from our engineering team as well. I think I agree, but I also am not a design engineer, so I will reserve vote, and if it's a majority, then we don't need to worry.
Okay, I'm gonna process this if everybody agrees, and we'll be able to get to collect further comments after sharing it with the broader community in a more final version. So, all right, thanks, Bo.
Yeah, I'm actually a fluid expert, so for me, is this I understand the method, but I think it's the go or no goes needs to come from the tank builders and the people who are really building this. So I will withhold my
Absolutely,
vote.
but you're the one who's in the call, so I just want to make sure the
Yeah,
no
problem.
Right, everybody will, all the parties will have an opportunity to review it further. Jeff.
Yeah, I'm okay with it, and like the broader community will have input, so I'm okay with it at this point.
All right, Kevin. You're muted, Kevin. All right, Kevin is not responsive. Martin.
Yeah, I concur with Bo and Amy. Not an expert here, but
okay.
Yeah, I'm not gonna obstruct this.
Good, Miguel. Miguel still not audible. Xineng.
Yeah, so I'm not expertise on this area, but I think it's okay for me to move forward with the broader community review.
Okay, very good. I will process this as it's updated here, and I will work it into the document. Then at least we have all these items covered. I will share it with the group that is now not present and represented, that is listed in the table of modifications, and make sure that we're all in agreement with those as well. So I think that pretty much concludes the open items for this. Next meeting, we should be able to vote on the completion of the document. Hopefully, assuming that the ACF fluids and materials input has been processed. Just scrolling through whether there's anything missing. I did have some comments still open in the document. I think it's further up. But okay, are there any further questions or suggestions that we must take into account before publication?
Yeah, hey, I was just catching up on the document, Rolf. This is my first time back in the OCP for a bit. So just going to clause 3.2, the safety requirements. And if you go to SR 325, I understand that this is just being generic in nature. Any electrical circuit must be fully certified in line with requirements which apply, geographical areas. So any regulation requirements and stuff, I understand we want to be generic there. But if we go to the next page under liquid management, and you go to the very first one, it kind of references just as examples like CEPED pressure equipment directives. So under safety requirements, you could maybe do the same, examples as, the low voltage directive or things like that, CE low voltage directives and things like that, just to be consistent. So just wanted to give you a general comment there.
Yeah.
Because that could be CE
Yes.
requirements too, right?
Yeah, absolutely, absolutely. And CE is a broad regional element. I think if I recall correctly, and this was a long time ago, I can tell you that. I think at the time we did consider it. I'm happy to bring it in though, but we didn't do it because these directives are already very well known in our industry.
Okay.
Whereas on the fluid side, it's not necessarily known, and therefore we included a few points that people may not logically arrive on if they do their research. So I think at the time we decided, okay, yeah, let's do it here because it points people in the right direction. Whereas the electrical certification, it's inherent to our business in the data center industry and the IT industry.
Okay. And I just wanted to bring that comment.
Okay. No, it's good. It's a good comment. We've been trying to avoid as much as we can with that because because we would have to put examples in a lot more requirements if we did it. So
I understand.
That's in the background. Is that some? I'm open to your suggestion, right? So with this as a background behind it, do you still want to propose it? I'm happy to do it.
I just wanted to make a comment. I mean, the users of this document, they're probably not going to have a regulatory background, so they may or may not understand what that means, and adding an example could be beneficial. I'm okay either way because I think what you just mentioned, it's going to be in the common community of your business. People, or typically larger companies, will have regulatory people which will understand that. So I'm good either way. I was just making a comment to see if we need to be a little bit more consistent from one section to another.
Yeah, does anybody want to back that up, want to support that, or does the majority here feel like let's not touch anything else?
Yeah, when we wrote this originally, there was a lot of discussion, and we decided that, we didn't want to lengthen the document unnecessarily by listing things that would be obvious at some time or another. So there's very few localities where, like I had to ship some equipment over to Turkey. They won't even let it in the country if it doesn't have a CE marking. So, there's just, you're going to come up against the regulations sometime in this process. And listing every organization that you have to comply with and everything, we decided was just, unnecessary.
Yeah.
Eventually, everybody comes, every organization is going to come up against this somehow, unless their country just doesn't care, and they're selling locally. So.
Yeah, and that's what I got from it. So that's fair. I'm okay leaving as it is, and I think Kevin and Rolf, you're right. I mean, you're going to come across this, and like you said, you can't illegally market unless you meet the regulations. But I just wanted to make that as a comment. And then just one other comment, Rolf. I reached out to you a few weeks ago just to be brought back into this. Is there any way that you can give me an update on with the liaison with the 62368 group, the HBSDT? I'm on that group, and I'm offering my support to this team to help with the auto ignition, effort on trying to reduce the temperature of that. So just keep me posted how you want me to be involved with it.
Absolutely, and this is one of the things that Michael will be taking the lead on in this group as well. Right now, this document is in the way of progressing those discussions. To be honest, because
Okay.
this is something that we need to complete and get out, and that is already a time-consuming process with the community consensus body. But yeah, we do have a very high priority on the flashpoint and auto ignition point discussions, and we do want to give all the space for that as soon as we can clear this into the publication. So yeah, that will be in this forum as well as the fluids and materials group.
Okay, great. So just keep me posted, and I'll attend these meetings, and as the team needs me or whatever, I can play a helpful role there, hopefully.
Yes, absolutely, and it will take place. Michael, I don't know if you have a view on when we can start shaping the work around it. I would guess after the regional summit.
Okay.
I'm not sure. What do you think, Michael?
That's fine. I was thinking, yeah, we could get this what we're working on right now, get that behind us, and then jump into that. And yeah, Jeff, I've been talking to Tom Burke on my side, and I know you've talked to him directly as well. So
Yeah.
sort of circle around with the right people that are involved in the committee work, and then what's happening here in OCP, and then sort of connect the dots and see what we can do.
Yeah, that sounds good, Michael. That's I've reached out to Tom. Tom and we kind of summarized things from IAC 62368 on some of the concerns, and we can start working that when the timing is. So just reach out to me when you kick this kind of off, and I'll be there to help out.
Okay, great. Thanks.
Yeah, just make sure you dial into these meetings, because I think the next meeting is just going to be about the completion and the final publication of this document and the final review circle. So we won't be getting into the subject matter as much as we've done so far. So we should be able to start scoping this out on the next meetings.
Sounds good. Thanks.
Appreciate the input. And for the record, John Bean and I are the industry liaisons, but we're not going to do it by ourselves. All the subject matter that we will be representing and that we'll be vocal about will need to be carried by a larger group, and that's something that we're looking at this group for.
Yeah, exactly. We got to put a strategy together, and we're going to have to put some data together to demonstrate that our rationale for lowering the auto ignition temperature, and have all that put together, so we can kick those discussions off when we get there.
All right, fantastic. Well, looking forward to that, and that's a shout out to all the others that have arrived today. I think for quite a few of you, that discussion will be even more interesting and more valuable. It is a discussion that we're also having and going to continue in the fluids and materials group. So we're going to have to look at appropriate way of dividing the angle to which we're discussing. We're going to be discussing it in these various groups as well. So, and Amy is one of the drivers behind some of the most recent content and information. Very grateful for that again, Amy. So I will be looking at you as well quite a bit for helping us progress that. And for now, I'm going to stop the recording. Thank you all for today, and